This is a quick review of right triangle trig. Before we get into the right triangle trig, let's talk about the 6 trig functions. Our first 3 trig functions, remember, are sine, cosine, and tangent. Our second 3, which you might not remember, are going to be cosecant, secant, and cotangent. Now the second 3 trig functions are simply reciprocals of the first 3. So sine and cosecant are going to go together, cosine and secant will go together, and tangent and cotangent will go together. We will use this property when asking us to find the 6 trig ratios of the triangle. Like I mentioned, we're just going to talk about right triangle trig today. So it's important to remember from geometry our SOHCAHTOA. That's how we're going to get the definitions of the 6 trig functions. So starting off with sine. Sine's going to be opposite over hypotenuse. That means cosecant, since it's the reciprocal, is going to be hypotenuse over opposite. Cosine, the co, is going to be adjacent over hypotenuse. Again, secant is the reciprocal of cosine, so secant's going to be hypotenuse over adjacent. And then we have tan, which goes with the TOA part of SOHCAHTOA, is going to be opposite over adjacent, so cotangent's going to be adjacent over opposite. Alright, let's go ahead and look at the first example. It's asking for the given triangle, calculate all 6 trig functions. So we are going to use the definitions that we just copied down in the table. So if I'm working from theta, so I'm working from this bottom right angle, the sine function is going to be opposite over hypotenuse. So that means the sine is going to be 7 over 15. Cosine, still working from theta, is going to be adjacent over hypotenuse. So therefore the cosine is going to be 11 over 15. Then finally tangent. Tangent's going to be opposite over adjacent. So therefore tangent's going to be 7 over 11. Now instead of referring to the table for the definitions of cosecant, secant, and cotangent, we're just going to use the property that we know the last 3 trig functions are simply the reciprocal of the first 3. Remember, reciprocal means you're just flipping the fraction. So that means the cosecant function is going to equal 15 over 7, since it goes with sine. Do the same thing for secant, flip cosine, so you will get 15 over 11. And then do the same thing for cotangent, so we'll get 11 over 7. Alright, now we're going to move into something that might be a little bit different than what you saw in geometry. We are going to be asked to solve the triangle. When you are asked to solve the triangle, you want to find, oops, sorry there, let me move that back. You want to find all the missing sides and angles. So again, when solving the triangle, we want to find all the missing sides and angles. So it's going to be important. You're just going to be given random numbers. You're going to be given what alpha equals, what beta equals, and so on. So you're going to have to draw a triangle. The way I set up my triangle is I'm always going to put my right triangle in the bottom left, or sorry, my right angle in the bottom left. It does not matter where you put alpha or where you put beta. For right now, I'm always going to put alpha on the top and beta on the bottom. But this has to be true. Little a has to be across from alpha. Little b has to be across from beta, and c is always going to be your hypotenuse. So that is very important. Even though it does not matter where you put alpha and beta, alpha and a have to be across from one another. Beta and b have to be across from one another. And then c is always going to be the hypotenuse. And remember, the hypotenuse is always across from the right angle. Alright, example 3 is asking us to solve the triangle. So the first step is we want to go ahead and draw our right triangle. Once you have your right triangle drawn, you're going to go ahead and start putting in your given information. So I'm going to go ahead and put beta on the bottom. So that means b is going across from beta. Alpha is going to go up top, so little a is across, so that side's going to be 20. And then c is always going to be my hypotenuse. Now the first thing we can go ahead and solve for is going to be alpha. We don't even have to use trig. We're just going to use the property that we should know that all our angles should be adding up to 180 degrees. So to find alpha, I'm going to take 180 minus 52 minus 90. If we do that, we should get alpha to be 38 degrees. So I'm going to go ahead, I have alpha as 38 degrees. So now I have found all my angles. Once you find all your angles, now we can go ahead and solve for the missing sides. I'm going to go ahead and find b first. Now it doesn't matter, you could find b or c first, it just depends on whatever you would like to do. I'm going to use only the given information, so I'm looking at 52 degrees. B is opposite, 20, my given side, is adjacent. So right away I know I'm going to use the tangent function, since tangent is opposite over adjacent. So it's going to be the tangent of 52 equals b over 20. Now to get b by itself, all we're going to do is multiply both sides by 20. So 20 times the tangent of 52 equals b. So that means you're just going to enter that straight into your calculator like you see it there, and you should get 25.6. So b is 25.6. Once we have b, notice now we have two sides. You can use the Pythagorean theorem if you would like. I always use my given information, so I'm going to go ahead and use trig again. I'm still working from the 52-degree angle. I'm given my adjacent side 20, and I'm looking for my hypotenuse. So I'm going to use the cosine function. So cosine of 52 equals 20 over c. Same idea as what we did before. We're going to go ahead and multiply both sides by c. So we'll get the cosine of 52 equals 20. Now to get c by itself, you're going to go ahead and divide both sides by the cosine of 52. So you'll get 20 divided by the cosine of 52. Go ahead and enter that in your calculator, and you should get 32.5. So c is going to be 32.5. Now a quick way you can check your answers. The smallest side, which in this case is A, should be across from the smallest angle, which happens to be alpha. C, your hypotenuse, should always be your largest side because 90 degrees is going to be your largest angle. So in this case, everything matches up, so that looks like a correct answer. Alright, we're going to start example 4 just like we started example 3. We're going to go ahead and draw a right triangle using our given information. And in this case, we're only given our 90-degree angle. So I'm going to go ahead and label alpha and beta. I'm going to put alpha up top, beta on the bottom. So little a is going to go across from alpha. So my base is 8.4. Little b is going to go across from beta, so that's 11.5, and we do not know what c is. Now again, If we take a look here, we don't have to use trig for the first thing that we solve for. In this case, the first thing we're going to solve for is little c. We're given two sides, so we can go ahead and find the third side by using the Pythagorean theorem. So it's going to be 8.4 squared plus 11.5 squared equals c squared. If I go ahead and just enter 8.4 squared plus 11.5 squared in our calculator, you will get 202.81 equals c squared. Now we just want c, so to get rid of the squared, you're just going to take the square root of both sides. Once you take the square root, you'll get 14.2. So 14.2 equals c. So now I have all my sides solved for. So now we can go ahead and move on to our angles. Now again, it does not matter which one you solve for first. You can solve for alpha or beta. In this case, I'm going to solve for alpha. So if I'm solving for alpha, 8.4 is opposite, 11.5 is adjacent. So opposite over adjacent tells me I'm going to use the tangent function. So it's going to be the tangent of alpha equals 8.4 over 11.5. Now, in this case, we're solving for an angle. Since we're solving for an angle, to undo the tangent, we're going to take the inverse of both sides. So you have to do second tan in your calculator, parentheses 8.4 divided by 11.5. So whenever we're solving for an angle, we're going to have to use the inverse. So that way when we enter that in our calculator, we should be getting approximately 36 degrees. I went ahead and just rounded to the nearest degree to make things easier. So I just rounded to 36 degrees. Now the last thing that we need to find is beta. Again, we have two angles now. We have 36 degrees and 90 degrees. So it makes it easy to find beta. All we have to do is you're going to take 180 minus 36 minus 90, and we should be getting 54 degrees. So now we have everything that we need. Again, double check and make sure your smallest angle and smallest side are across from one another. So 36 is my smallest angle, 8.4 is my smallest side. Check the largest. My largest side is 14.2. My largest angle is 90, so everything matches up. Alright, the last example. It says if cosine of alpha is 3 over 4, we want to find the other 5 trig ratios. So the first thing we're going to do is we're going to look at cosine, the given information. So cosine alpha is 3 over 4. Now going back and using SOHCAHTOA, the definition of cosine is adjacent over hypotenuse. So basically our given information is telling me that my adjacent side is 3 and my hypotenuse is 4. So the first thing you want to do is go ahead and draw a triangle. I'm going to go ahead and put the angle on the bottom. So that's the angle I'm going to work from. That's alpha. So it's saying my adjacent is 3, my hypotenuse is 4. Now we're going to go ahead and we have to go ahead and find this missing side if we want to go ahead and find the other 5 trig ratios. So to find that missing side, you're going to use the Pythagorean theorem. So I'm going to use 4 squared equals 3 squared plus, and for right now I'm just going to call it x squared. Now if you take 4 squared minus 3 squared, you'll get 7. So 7 equals x squared. Go ahead and take the square root of both sides. So we're getting this missing side to be the square root of 7. Now that we have all our sides, we can go ahead and find the remaining 5 trig functions. So the first one that we're going to start off with is the sine function. So if I have sine of alpha, so the sine of alpha is going to be opposite over hypotenuse. So it's going to be the square root of 7 over 4. Then we already have cosine, so there's no need to write that down again. So I'm going to go ahead and go to tangent. So the tangent of alpha, tangent's going to be opposite over adjacent. So the tangent's going to be the square root of 7 over 3. Then we're going to go to our last three trig functions, which starts with cosecant. So we have cosecant. Now, all we have to do, cosecant's the reciprocal of sine, so you're going to flip this fraction right here. Well, notice if you flip it, we're going to get a radical on the bottom. So what we have to do is rationalize it. So our final answer should be 4 radical 7 over 7. Then we go to secant. Remember, secant's the reciprocal of cosine, so you're just going to flip that fraction, and we should get 4 over 3. And then our last one's cotangent. Sorry for my handwriting. Cotangent. Again, cotangent's going to be the reciprocal of tangent. We're going to have a radical on the bottom, so we have to rationalize it. So our final answer is going to be 3 square root of 7 over 7. Hopefully you find this helpful. If you didn't quite remember everything about SOHCAHTOA, hopefully this is a nice little review to help you.